All right. So let's take a look at law of sines today. By the way, how did y'all do on law of cosines? Y'all feel okay about it? It's really easy just to copy those answers off Schoology and then suffer a painful death. Now remember, we're shifting into the law of sines today. So law of cosines we have to use in what two circumstances? If I start you off with side, 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 or side, angle, side. And how do you tell the difference between a side, angle, side, which has two sides and an angle, and a side, side, angle, which we're going to talk about today? What did I say about side, angle, sides? Every letter is accounted for. So all A, B, C, X, Y, Z, whatever, however they label, you'd have one different letter of each. All right? So today we're going to look at the rest. Now, all the rest of the situations, whether it's angle, angle, side, or angle, side, angle, or side, side, angle, all of those, we are forced to start with law of sines. Because those are the only ones that I can fit. The law of sines is the only equation I can fit my information into. So real quickly, I want to show you the proof for the law of sines, which really is dependent on our area formulas that we technically don't know. But I'm going to show you the area formula. And then we're going to manipulate them a little bit to get our law of sines. But you don't have to memorize this. I just wanted to show you. So hypothetically, what if I, again, put some random oblique triangle out here, and I placed it on the y-x-axis? Okay? Heck, I don't even have to do that. Forget the y-x-axis. What if I just have a random triangle, and I'm going to call that A, that angle B, that angle C. I know I'm putting little things, so that doesn't mean they're equal. I'm just saying they're angles. And then this would be side B, side A, side C. And I asked you, what is the area of this? Now, if you knew all these values, and you happen to know the Heron's formula, which I think you learned back in geometry, you might have forgotten it. But if you knew that, you could find area that way if you knew all three sides. But I want to talk about area of a triangle. Now, if I'm finding area of a triangle, I have an area formula that I've known since the dawn of man, which is what? 1/2 base times height. Problem is, I know the base, but I do not know this height. Well, assuming I know all the sides and all the angles, could I find this height if I just drop that straight down, if it makes, say, a 90-degree angle right there? And we talked about this a little bit yesterday. Can I find H using right triangle trig? Yeah, what would you do? Or one thing you could do. Sine of A is what? So if sine of A, based on this part of the triangle, is opposite over hypotenuse, that would be H over C. And then I could just slide the C over or multiply both sides by C, and I get my height. So back to my area formula. Area based on this triangle would be 1/2 times the base, which looks like the whole thing is B, times the height, which would be C sine A. You with me? Now, what do you think happens if instead of labeling this A, B, C and A, B, C like this, what if instead I labeled it top A, bottom B, C, C, bottom A, B? Now what do you have? Forget this. Now what happens? Now how do I find the height? Same way, right? Different stuff. Sine of C is H over B, multiplied by B. B sine C is height. 1/2 area, therefore, is 1/2, except now what's my base? A, and my height, B sine C. Can I move this around again? What do you think I'm going to get if I move them around again, just based on patterns that you see here? Somebody. If the first one's BC sine A, and this is AB sine C, what do you think this one's going to be? AC sine B. Right? And they're all three different ways to find the area of the same triangle, right? So if they're all the same triangle based on different labeling, then aren't all those areas the same? All right, here we go. So what that means is 1/2 BC sine A is the same thing as 1/2 AC sine B is the same as 1/2 AB sine C. Now, technically, you could argue that's the law of sines, but nobody likes that one. So here's what they did. They divided everything by 1/2. That made that better. And then they divided everything by ABC. And it's algebra, you're allowed to do that. And in this case, it canceled out the B and the C, leaving me sine A over A. In this case, it canceled out the A and the C, leaving me sine of B over B. And in this case, it canceled out the A and the B, leaving me sine of C over C. And that is much easier to memorize. And that is all you need to know for law of sines. And remember, law of sines is a three-part equation, but we're never going to use all three parts at the same time. But because they're all equal, you can pick any two of those three that you want and use that as your formula. So we already have a great plan. So you don't have to memorize this. I just want to show you where it came from in case you just thought it was a mystery or really wanted to know. So we've already got a plan. You just said for side, 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 and side, angle, side. We always use law of cosines to begin, right? And last night, did anybody use law of sines? Like, did anybody look ahead or remember it and use law of sines to finish up? Okay, normally no, people, every now and then there's a random person. So if I begin with law of cosines, I can end with law of cosines, right? It's a loyal, faithful dog. It's not going to turn on me. I mean, listen, dogs, if you are nice to dogs, I mean, if you're mean to dogs, they may turn on you, but whatever. Law of cosines, it's your friend. It's not going to lie to you. And we talked about why. Because anytime you're solving for an angle in law of cosines and you do inverse cosine, why aren't you ever worrying? Because inverse cosine is defined from 0 to 180. So you're safe. But now we're entering into law of sines. Law of sines information won't fit into the law of cosines. It won't. You'll see that real clearly. But it will fit into this. But the problem is if you're finding an angle here, you're going to eventually have to inverse sine something, right? Right? And when I inverse sine something, the inverse sine equation was defined where? Not 0 to 180, negative 90 to 90, which means if you ever are finding an angle that could be obtuse, there's a chance law of cosines will lie to you. It'll give you an answer if there is one, but it might be lying. It might tell you 80 when it's really 100. It might tell you 34 when it's really 146. I mean, it'll do that, and you won't know unless you're on your game. And actually, sometimes it'll tell you 34, and there's two answers. It could be 34 or 146. We'll have to walk through all that stuff tomorrow, but today you're not going to run into it. Actually, I take that back. I think the very last problem, when you do it, I don't know why they did this in this book, but I kind of left it. If I still have that on there. There's one problem in there when you do it, you get it right, and you look to the back of the book, and you're like, why are there two answers? And they're just doing that to make you go, what? And make you think a little bit. And that will cover that tomorrow. But anyway, those two with law of sines, all the rest, side, side, angle, right? No angle, side, sides around here. Angle, side, angle. Or angle, angle, side. And by the way, you'll never have an angle, angle, angle given to you because if I have three angles, can I find sides from just that? No, so you don't have to worry about this. All of these, law of sines to begin. And most of the time when you begin, you end with them. Now, let me just talk about side-side angle and angle-side angle. Obviously, angle-side angle and side-side angle, I really don't even differentiate between the two. Like I'm going to mention it, but then I really don't differentiate. And the reason why is if I know two angles of a triangle, what am I always able to find really easily? The third one. So really, it doesn't really matter to me whether it looks like this, whether I'm giving you, like this would be angle side angle. I would be giving you this angle. I don't know, what does that look like? I would be giving you this angle, and I would be giving you the side in the middle. That's angle side angle, right? As opposed to angle side, which would be like me giving you 88, then 46, and then telling you this was 13. That would be angle side. But I don't really care because ultimately, if I know 2, I can always find that third angle, right? And if I can find the third one, basically, you have all the angles, 120, 134, what's that, 46? I have all the angles and a side. But on any of these, I'm going to go to law of sines. Think about it. How would you even put that into the law of cosines? There's places for 3 sides and 1 angle. So you can only fit 1 angle in, right? And then you can only fit 1 side in. So you're still missing 2 variables. You can't solve for jack when you have 2 missing different variables, right? Or even if I have side angle. What if I had something like this? This would be like angle B. This would be side B. And maybe this is A or C. I don't know. Just depend on what those were. How do you fit that into the law of cosines? We talked about that briefly. If you try, you end up, if you have the A and the B in there, you end up having a C squared and a C left over, and you'd have to use a quadratic formula. And the problem with that is the quadratic formula always spits out something plus something over something and something minus something, which gives you 2 answers. Which one is it? Well, I don't know. Well, it's only one, but you're not going to know. Well, most of the time it's only one. It'll only be 1 to 9. So we're not going to use any of that with law of cosines. We're going to use law of sines. But what am I going to be careful about? When I look at a situation, and you're not, again, not going to see it tonight, but let me ask you a question. What if I were to tell you A is 10 and B is 12 and angle B is 48 degrees? All right? Now think about law of sines right here. Law of sines because I'm given 2 B's and an A. This is not a side angle side situation, even though there's 2 sides in angle. And how can you tell that it's not side angle side? Because it's not ABC. And if you look on a triangle, you can see B, A, B. Oh yeah, that's clearly what? Side connected to side connected to angle. But I don't even draw a picture. I just go matching side and angle. 2 sides must be side angle. Now look what happens when I plug this in here. Right? I don't have any information about C, so I'm not even going to use that part. All right, so I'm going to plug the B in right there, sine of 48. I'm going to plug that B in here. I'm going to plug that 10 down below, and I don't know angle A. So what are you solving for here? You're finding angle A. Now I have a question for you. Can you give me any information about angle A before you type this into your calculator? Is there any commentary you can make about angle A based on this information right here? Smaller than 48. Do y'all see that? And if it's smaller than 48, it's definitely what? Acute or obtuse? Definitely acute. And if we're going to end up using inverse sine, because at some point, think about it, I'm going to have to multiply by 10. And when I multiply 10 by the sine of 48 and by 12, I'm going to end up getting some decimal, aren't I? Or something, right? And my next step would be to do what? What's my next step right here? Inverse sine. Oh, crap. There goes that inverse sine equation. And when I inverse sine, my answer is going to get spit out between what and what? Negative 90, 90. In this case, 0 to 90 because they're all positive. So it's going to be an acute angle. Am I worried about that being acute? No, I know it's going to be a Q. So this is an example of what you're going to see tonight. You're not going to run into any issues. Law of sines is not going to be nasty to you. And once I find angle A, I'm kind of home free, right? Because if I find angle A and I already have angle B, can I find angle C? Right? And then once I have angle C, all I need is side C. And side C's, if you really think about it, I never use inverse sines to find side C's. Right? Think about it. Once I have my information, like say I'm using this. Say I'm using sine B over B and sine C over C. To find side C, I won't need to inverse sine anything. I'm just going to sign stuff. Signing stuff's great. It's the inverse signing that's a problem. And I only inverse sine stuff when I'm finding angles. And I already have my angles. So this problem will not be a problem for us with law of sines. But what if this was true? Now give me a commentary on angle B. What do you know? Angle B is larger. Angle A is larger than angle B. Do y'all see that? How much larger? I don't know. Do you know? Are you able to kind of look at those proportions and tell? I can't. So I have no idea. So if it's larger, let me ask you this question. If it's larger, it could be larger by a little bit and still end up being 70 degrees. And that would be great. It could be larger and be 86 degrees. And that would be great. But it could also larger and be 110 degrees. Why would that not be great? Because inverse sine won't give me that answer. This is called the ambiguous case of side-side angle. It's this specific kind of situation where when you're looking at it, you look at it and you go, wait a minute. That angle that I'm about to solve for could be obtuse because I know it's bigger. I just don't know how much bigger. It could be. And when that happens, that's what we're going to focus on tomorrow. But you're going to be really ready for it because I've been talking about it for 2 days. That's the hardest part about this chapter. When that happens, you go, crap. What that means is I could actually get 2 separate triangles from this information. And I'll show you that tomorrow. I can take this and draw 2 completely different triangles. But the math completely makes sense. And we'll talk about the math. But not today. Today, you're going to have it easy. That information is going to always be where you're like, oh, it's going to be acute, so no problem. All right? Now, the other, so side, angle. So to finish walking through this, here's what I would do. My first step would be, all right, I'm definitely going to I have to find angle A first. So to find angle A first, but I'm going to need A, then C, then C. Those are the things I would need to solve this triangle. So taking out my calculator, hopefully you're getting better and better on whatever version of a calculator. Anybody order and Inspire?
I did.
Nice. So Lily's gotten hers in. Nobody else ordered one? You're going to like it. Very nice. Do what?
JW got one from Target.
Target? What'd you pay? Was it a lot more?
It was on sale.
Really?
My mom said this one was a lot. It was from like Office Depot.
Well, with tax now, it used to be always cheaper on Amazon because you didn't have to pay tax. But now you have to pay tax on Amazon. It's roughly $150. So yeah, that's great. If it's only $130 at Target, go. It's a steal. Guy, you're gonna have to have one, or an 84. And 84 is a little cheaper most of the time, but you're gonna need one. Unless you decide to just go, man, I'm going math and society. I don't even know what math courses are offered around here anymore. There used to be something called math and society. That was for like, I'm out. I just want to have the easiest course possible. But you're going to need an Inspire. If you know for a fact, beyond certainty, that you are not going to take pre-cal math team next year, if you know that, you're like, I don't care, I'm out. I had a girl once had 97 average in this class, super stressed all the time. I'm like, why are you stressed? It's so hard. I'm like, well, just don't study as hard, make a 91. Like, why are you trying to kill yourself for 97, 98? So she was out. So bored. You'll be bored. Ask Caroline Crimmy. That was pre-cal this year. So boring. But whatever. For some people, it'll be like, boring's kind of nice. Listen, I'm an old guy, man. I like going home. What are you doing this weekend? Absolutely nothing. Puts a smile on my face. So I get it. So if you want a little break, whatever. But just know this is still a better calculator than the 84, but they teach from the 84. So if you don't want to have to think as much, or maybe ask as many friends how to do stuff, 84 is great. I use them all the time. I use them for so many years, it's burned into my brain. Like for 20 years, almost I used an 84, an 83, or an 82. Heck, I even have an 81. It's an antique. Welly found it in some cabinet and gave it to me. But yeah, but it's I have some antique calculators. I have one calculator that's like as big as a laptop that TI made for a little bit. It's called the TI-92. And it actually graphs in 3 dimensions. You can rotate it, but it had this QWERTY keyboard on it. And everybody was like, illegal. People were like, I just spent $200 on this. And this was like 20 years ago. It quickly, I still have it though. It's in my other desk in my other room. It takes like 6 AA batteries. It's like this massive thing. Anyway, whatever. But I think this is a better calculator. I'd still get it. It's more long-term. And if you want to dump it when you get to college, you're like, I'm going to be an English major, and you're dumping it, you can sell this a lot better than you can sell the 84. Go on eBay. You're not an eBay buyer and seller, man, you make some serious cash. Whatever. Or get stuff super cheap too. So we're going to type this on our calculator. Tell me if I do something wrong so I don't waste our time here. 10 sine of 48. And we're going to divide that by 12 to get this ratio. So the sine of the angle A gives me the ratio 0.61929. All right, whatever that means based on the right triangle that's in the middle of all this. And then when I inverse sine that, so inverse sine the answer, I get 38.26. So I'm bringing that decimal down, and I inverse sine the answer, and I get 38.26. And just as I thought, smaller than angle B, right? At this point, angle C is chopped, so this is 38.26. Angle C should be child's play, right? You take your 180, you subtract the given 48, and since you have the angle in as your answer, I go minus answer, spits out 93.74. Right? And then the last thing you need to do is find side C. What do you want to do to find side C? Law of sines or law of cosines? Your call. You like law of cosines? Pull out the C squared equation, put it all in there. It's nice because it's all on one side. Type it all in, square root it. So if I was finding C right here, you could say C squared is the A squared plus the B squared minus 2 times the A times the B times the cosine of the C. That's actually not a terrible idea because you're sitting with that C right there. And then you got to square root whatever you get as an answer. So 10 squared, it's a little more button pushes, plus 12 squared minus 2 times 10 times 12 times trig cosine of the answer. So I got it all in there. Gives me 259.6377. 259.63776, yada, yada, yada. I square root that. So square root the answer, and I get 16.11. And this is if I'm rounding everything to the hundreds. But if you don't like law of cosines, then you go and say, well, I would have to use some law of sines that includes C, right? And if it were me, I would use those. Can anybody tell me why? Yeah, and I'm still going to have to use angle C, right? So I'm going to have to use something. But at least it allows me to use 2 values that haven't been rounded. But guys, I'm going to be exact. I'm never going to use a rounded value because they're right here. If I have an Inspire, I can go grab them. And even if you don't, as long as you write out like 4 or 5 decimals, you'll probably be fine. But you don't want to use reuse rounded values. That's going to it's going to cost you something. Not a ton. I told you that story. True story. They were built, I-10 travels from like Gainesville, Florida, I think it is, all the way through, you cross it when you're going to the beach, runs along there, comes up through Texas, goes through Dallas, goes back down through El Paso, up through Las Cruces, New Mexico. I've driven it. Yeah, Las Cruces, New Mexico, cruises up through Tucson, up through Phoenix. And it used to stop in Phoenix. And then Phoenix was like this massive land mass of spread out houses. And then it would pick up on the other side of Phoenix and head to LA. So they're joining these 2 places in Phoenix. True story. they're joining them and they're working from both sides, kind of like when they did the railroad back in the day when we're going to meet right here and tie it together with a gold spike or whatever. And they're doing like this. Some guy makes a rounding error, and the roads aren't going to align. They're getting them together and they realize we're going to be like this, not like this. And you're like, how could that happen? They traced it back to a rounding error where a guy uses a rounded value on some of the engineering, just what he did. And they could just go, oh man, just put an embankment in there. We'll just go full on NASCAR for a couple hundred yards. It'll be great. Yeah, they can't. Had to rip sections down. Hundreds of millions of dollars they had to rip down. Do you want to be that guy? I mean, can you imagine? Who's this idiot? And it's you because you rounded badly, because you had a crappy calculator, not a TI Inspire. Okay? Anyway, you gotta be careful. But I gotta use this, but this puts me in probably the best situation to find my C. So I would do this. If I'm trying to solve for this little C, you can cross multiply and divide, or you can slide the C up, slide the B up, slide that down. Y'all tracking with me? And that will give you your C there on top. And if you already have stuff in there, or even if you don't, you can say, all right, I got 10 times sine, keeping in mind the last thing I found was that. So I can do sine of my answer, and then divide it by sine of B. And you can literally have this for your side C, and it spits out the same thing if you have it rounded. Easy enough? Law of sines. And again, you're not going to run into bad, hairy situations, like Miss Tiger would say. You're not going to run into that tonight, the biggest case. That'll be tomorrow night. But tomorrow you should be really ready for it because I've been talking about it for 2 days. All right, next situation. That was side angle. The other two, like I said before, whether I give you two angles and a side, or an angle side angle or an angle and a side, bottom line, you have all three angles and a side is the way I think about it. Unless you just happen to add wrong or subtract wrong. So let's check this out. So again, if I gave you, this is the only one that could potentially confuse you, I think. What if I told you that A is 12 degrees, C is 79 degrees, and B is 20. All right? Now, every now and then somebody goes, oh, wait a minute, all the letters are different. He said when all the letters are different, I use law of cosines. Well, I did say that, but I said with this exception. And how are you going to get that into law of cosines anyway, right? So that's the one exception where all three letters are represented, but you can't fit that in law of cosines. So we're still going to go to law of sines. Problem is I can't fit it in law of sines either until I do what? Find the next angle. So once I find angle B by going 180 minus 12 minus 79, which is 91. So that gives me what, 89 degrees? Is that right?
Yeah.
Okay. I'll tell you what. I don't know why I don't like this. Make that 12 a 22. So that's 79. Yeah, I like that better for some reason. All right, so now I have this information. So what would you do? You're still missing side A, side B. No, side A, side C. So you already found this, but you're still missing this. So what would you do to use law of sines? Because you still can't use law of cosines. Which two parts?
Is it smaller?
I love that thinking. She said, find A, because if you look at A, C, and B right here, actually, hold on. I like the thinking, but remember, we don't have to worry about finding sides, right? Because the only time you use an inverse sine is to do what? Find that angle. We got all the angles, so we're safe. But I do like that you're constantly thinking about that. So yeah, finding the smallest angle is always a great idea, but I already have all three angles, so I have no worries at this point. So what do you have to use here in the law of sines? I've got to use either sine A over A, sine B over B, or sine C over C, which means I'm going to have to know an angle side combo, right? And the only angle side combo I have is what? B and B. So I know I have to use that part. Because again, I got to fit this stuff in here. So B was 79 and angle B is 20. Okay, great. And then at this point I can find each one. Which one do you want to do first? A, so sine of 22 over side A. But I can do either one at this point. Now how do you find A here? Cross multiply and divide? Or slide the A up. All right, slide the A up, the sine of 79 down, and the 20 up. And by the way, guys, if this slide rule is really annoying you and bothering you, look, you're only saving a moment. Look, cross multiplying A sine 79, 20 sine 22, divide by sine 79. I am not saving tons of time. Same thing. Heck, even cross multiplying is a made up rule. What you're really doing right here is saying, I want A on the top. I'm going to multiply both sides by an A. Now A is on the top. I want sine of 79 gone. I'm going to divide both sides by a sine of 79. And I want 20 gone. I'm going to multiply both sides by 20. A equals 20 sine 22 over sine 79. But if you like the slide rule like I do, knock yourself out. So I type it in my calculator. Am I worried about my calculator lying to me? Why not? Because it's not what? It's not an angle. I'm not doing an inverse sine, am I? I'm doing a regular sine. And remember, I know sometimes that's hard to wrap your brain around, but remember we graphed those yesterday? Regular sine goes forever. Inverse sine goes up. You're not going to have issues doing sine of something. Sine of something finds you ratios. Fine. Every triangle with a certain coterminal angle has the same ratio. No worries there. Well, your issue is when you're finding angles. Inverse signing certain ratios, sometimes the calculator lies. So when I take this and I divide it by sine of 79, spits out, everybody get this, 7 point something, 7.63. And then now that I have A, what do I need to find now?
Isn't C the same as B because the angle is the same?
Oh yeah, sure enough. Didn't really want that to happen either. What happens when you make crap up? But yes, so at this point you could go, oh, look at that. C is also good. Rarely will that happen though. Okay, didn't even notice that. Y'all with me? Think about anything else I can throw at you. Tell you what, let me throw this at you. How much time we got? Oh, plenty. I'm going to show you why. This is really going to help you tomorrow too, maybe. And I have some people who are actually going to do what I do up here every time. And it makes the ambiguous case really easy. And the ambiguous case is that situation I told you about where it's like, well, I know it's bigger than that one, but I don't know how much bigger. Check this out. Side A is 10. Side B is 12. Angle B is 63 degrees. Do you have any concerns about this side-side angle situation? About the calculator lying to you? No. Why? Because when you find angle A, if side A is smaller than side B, angle A is smaller than angle B. And if that's true, I know for a fact that angle A is going to be acute and inverse sine is going to be fine with that, right? Now let me show you why it's fine with it. If you go to do the math on this, you're going to do sine of B over B equals sine of A over A, right? And then you're going to start multiplying by 10 to get rid of this stuff. And you're going to get down to this decimal. Now, when I do that, check it out. 10 sine 63 divided by 12. You get 0.13946-ish. Now remember a couple days ago, we were just doing problems like this, weren't we? I was saying, all right, guys, let's find all the angles. We weren't talking about a triangle at that point. I said, find all the angles that have that ratio. And you guys did this. You inverse sine. Normally it was flip-flopped on you, but you inverse sine this thing. And tell me if this rings a bell. I hope it does. You inverse sine this and got, what in the world am I reading? Okay, so this first part was wrong. Did y'all get something different? I'm guessing you did. Yeah, 0.7425. Is that right? Is that what y'all got? 0.7425. That's what happens when you don't have it in the right mode, so be careful. So then when I inverse sine the answer, I get 47.95. Anybody get this? We're just going to call it 0.9 on this one. Okay, now that's not what you did before. Before you did this. You did this. Okay, I need to make sure it's positive. It already was positive, so I didn't have to change anything, which means I'm actually finding the reference angle, aren't I? Right? And you found that reference angle. This is what you did before, and it was 47.9 degrees. And then you said, where would sine have positive values? And you said, well, that would be positive in the first and in the second, because all students, right? And that would mean that your first angle was 47.9, and your second angle would be 180 minus that, so 132.1. Now, this is what you would actually have done before, right? Before we were talking about triangles, except you also would have had a 360N on there. Now, let's think about this for a second. What is your first angle? The one given to you, 63. Is it even possible to have a triangle with a 63 and a 132? No, it's not even possible because I'm already over 180. And that is why I don't worry about this. And and obviously I can't add 360 to that. That puts me over 180 as well. That's why that's the only angle A I have. Are you seeing this? Now, look at this math. Now tell me what you know. Hold on, let me think about this for a second. That's going to be too big. How about if it's 14? Now tell me what you know.
Angle A can be bigger than 63.
Ooh, that's right. Angle A is going to be bigger than 63. How much bigger?
Who knows?
Who knows? Which means if you don't know, you could be in a safe place, could be acute, but it might be obtuse. You going to know the difference? Well, what if now I'm going to show you how to address these without doing this tomorrow, but what if we just said, let me just trust the math. Sine of 63 over 12 equals sine A over 14. Multiply both sides by a 14. And I get sine of A equals, this time, check it out, 14 sine of 63 divided by 12. Dang it, it's way too big. Make it 13. This actually is a does not exist triangle. I'm trying to make it work. Make it 13. I think 13 may. I'll talk more about this tomorrow. All right, this has been a great test question. Check it out. Inverse sine, it's already positive, so I don't have to make it positive. Inverse sine of 0.96525-ish. Check it out. $74.85, is that right? Okay. 74.85 would be my first angle one. But wait, where does sine have positive values? The first and the second? Right? There and there. So one of them would be 74.85. What would be the other one? So that's the first one. Of course, plus 360N, right? Now I'm going to show you a better way to do it than this. What would the second one be? 180 minus that? 105.15? Now, wait a second. Does this 74.85 add with that and still remain under 180? So there's still room for angle C, isn't there? Does this 105 add with that and still remain under 180? So there's two triangles that fit this situation. There's two. Now, you're not going to have to do all this because tomorrow I'm going to show you, and you're certainly not going to have to tonight. But tomorrow, because none of them are going to have this situation. This is the ambiguous case of SSA. But basically, it's this. If you ever look up there and go, wait a minute, the angle I'm about to find could be obtuse, you're going to have two triangles, or your calculator is going to spit out error. When I had 14 right there, it spit out error. Actually, it didn't quite spit out error, but I knew it was going to spit out error based on the number. But it would have spit out error. And if there's error, that means there's no triangle that fits this. And that's possible, isn't it? What if I said, hey, make a triangle out of this marker and this marker and a yardstick, which is 3 feet long. Can you make a triangle? No, sometimes stuff doesn't make triangles, right? What if I said, make a triangle out of a 63-degree angle, a side, so I don't know how long the sides are, and then a side that's 10, and then a side that's 3. Well, I can stretch all day, but I'm not going to get back there, am I? So sometimes stuff just doesn't work. When it doesn't work and you type in your calculator is really kind to you. 99.9% of the time it says error. And then occasionally it'll lie to you. I'm going to talk about that tomorrow. It'll lie to you, but when it lies to you, it lies good. Like it'll lie to you and go, all right, the angle is 120 degrees. Wait, 120 and 63 is already over 180. Throw it out. That kind of makes sense? Anyway, tonight should be smooth sailing on the law of sines. Once you start with law of sines, you can always end with it. But remember, you can always jump back to law of cosines after that first step or second step if you want. If you can fit it in there, you can use it. And guys, please come in with good questions tomorrow. And we will finish up tomorrow and review on.
Should we be able to finish our review tonight with everything we know?
That review and that quiz are not even on this stuff. Yeah. So I gave you till Monday. Oh, one other thing. I'm thinking about possibly moving our Pi Day to Monday, the 15th. And the reason is I'm getting that Pfizer test, that second one. I keep talking to people and they're like, yeah, the first one, I had a sore arm. The second one, I felt like I got beaten in the face.
Yeah, my brother.
My mom was sick for 2 days when she got sick.
Yeah. So my uncle just told me I look just like him. He told me he got it and didn't affect him a bit. But he never got COVID. It seems like everybody I talked to that's had COVID already, when they got that second shot, they really went down.
Yeah, my brother was.
My dad has COVID and got his second shot and just had a headache for like a day. That wasn't fine afterwards.
Yeah.
It's because they're giving you like a small bit of food, so if your body's like super reacting to it, they're just gonna go off.
Yeah.
My dad got the second one and he stayed in his room for like 2 days. He had like chills and like a really bad fever and stuff.
Yeah. Awesome.
Yeah.
Looking forward to it.
But my mom got it too and she doesn't have any symptoms. So it was like completely.
Your dad have red hair?
No.
Maybe it's the red hair thing.
Maybe it is red hair.
Well, I'm hoping for the best, but I don't want to not be here on the 12th and have the sub walk in here and go, what chaos is this? You know? So, because I'm the only math teacher I think who's doing Pi Day. I think everybody's bailed on it. Because they were doing it all on the 19th, and when they did that, they went, well, that's going to be your asynchronous learning. That's going to be, I hate that word, but they said that's going to be your free day, whatever. But anyway, I don't know. It's been a hard year. We deserve to at least have some day off, at least once. But anyway, I'm thinking about moving it to Monday. That might change some things up for our schedule. Like right now, your schedule says we're having Pi Day in our test, but that might really be better for you guys. That would move our test to the Friday instead of the Monday. So the end of next week, you would have a test on that, which honestly probably is better for you guys. So we might just do that and then have our pie day on that Monday. And anyway, and I'll probably pass a list around. If I have not mentioned this to you, I talked to Dr. Barnes and he said we could share food if it was individually wrapped. So if y'all want to make like cookies, brownies, I mean, I wouldn't individually wrap like cheese dip or soup or whatever, but you know, so it's not going to be as great, but, and obviously I'm going to try to hook a Wii up to this thing and maybe we could do something and just like disinfect the controllers every time we swap. We'll try to make the best of it. But we'll talk more about that next week.
Yeah, just bring your.
You could, totally, but it just takes that time to sync them. That's the only downside of it.
276. It's like
Yeah, whatever. You bring your own controller. I'll bring mine too. And I only have two. If anybody else can bring some to kind of share, but we'll just write them down as we go.
If you want us to try and beat Isaac and Mario, I'll play with one hand.
Are you the Mario Kart master?
Indeed. He does it like blindfolded.
Blindfolded.
Crazy. Pretty sure.
He knows every single
Yeah,
map.
it's like-
He
yeah,
knows
sure,
every
but-
single map. Don't play with him.
Don't play with it.
He doesn't get to play with us.
I wish.
Well, I stink. I've maybe played 3 times in my life.
What game?
Mario Kart.
My hands start
Like I've
shaking.
watched people play it for years, but I was just like, nah.
I'm so bad at that game. I like start shaking and then I
Really
think I
holds
keep
every
throwing
ball
up.
back here.
It's
I like
like
tennis.
Mario Kart.
Yeah, I
He was like Call of Duty.
Tennis on the Wii is
Face.
fun.
I like bowling.
Oh goodness,
Oh,
no,
wait,
they
wait, I got
shot
to where I could
I'm
bowl
so good at Call
300.
of Duty. And
That's a
Yeah,
stupid little, it looks like a real movement. It's like,
me.
I do this funny little thing. and it would just-
I am.
Always
I'm
a
gonna tell me how to play.
Yeah.
like baseball, and you would just do that. And find him.
Yeah, find those little loopholes.
Well, that was his basketball for
He went
seasons.
to this and I was-
Oh yeah, it just. Oh, it dropped right on the end.